Have you ever wondered how a thick, ordinary steel bar transforms into a colossal chain hundreds of meters long? These aren't just chains for operating machinery. They secure the modern world's largest cargo ships, hold anchors steady, and safeguard thousands of lives amidst the depths of the ocean. Let's embark on an epic journey, fueled by fire, pressure, and engineering, to see how these massive anchor chains are crafted. The process begins with thick, robust steel bars. These are no ordinary pieces of iron. They are made of high-grade, specialized steel designed to withstand immense pressure, corrosive saltwater, and years of continuous use. Massive bridge cranes lift these bars to kick off the production process. The first step is cutting. Using an automatic bandsaw for a cold cutting process, each bar is sliced to a precise length. Each cut segment is known as an ingot, weighing over 100 kilograms. A single anchor chain link will be forged from each of these ingots. The ingots are then arranged and fed into an induction furnace. Here, heat is generated not by open flames, but by an electromagnetic field that raises the temperature to 1,600 degrees Fahrenheit in mere seconds. The ingots become so hot that their surfaces glow a fiery red. Once they exit the furnace, the pressing stage begins. A massive hydraulic press first bends the ingot into a J shape. An operator then threads this heated link through the previously formed link. Next, the press applies hundreds of tons of pressure to clamp the two ends together, sealing them shut to form a complete link. But the work doesn't end there. Now comes the most critical stage, welding, specifically resistance butt welding. Copper electrodes firmly grip the heated link while a high voltage current is passed through it. The steel's resistance generates so much heat that the metal melts, fusing the two ends together permanently. As a result, the link is no longer in two pieces. It becomes a solid, seamless metal ring. A small amount of excess metal accumulates at the joint. This is sent to a special press to be trimmed away precisely, ensuring the link becomes completely smooth and uniform. While the links are being produced one after another, the studs, which sit in the center of each link, are being manufactured on an adjacent line. These studs prevent the links from twisting, bending, or deforming due to internal stress. Heated raw material is rapidly shaped into studs using the immense pressure of a large press. Hundreds of studs are produced every hour and collected in large containers. Meanwhile, the newly formed links are still red hot. An operator inserts a cool stud into the center of the link. As the hot link cools and contracts, it grips the stud tightly in place. A skilled welder then applies a small amount of weld to both sides of the stud to ensure it remains absolutely immovable under any conditions. Although the chain links are formed this way, the process doesn't end there. There is still the most critical component, the shackle. This shackle connects the anchor to the chain, so it must be even stronger than the links themselves. The process begins with a massive carbon steel block weighing 265 pounds, a block that takes over 15 minutes just to cut. Next, the block is placed in a furnace at 2,200 degrees Fahrenheit for several hours. Once it glows a fiery red, it is transferred to a 6,000-ton press, where the metal is shaped to form two broad ears and a thick body. Once reduced to a smaller size, the metal is reheated in a furnace. Then, a massive hydraulic bender gradually shapes the shackle into an arch. Before it cools, it is placed into a mold within a huge forging press. The immense pressure forces the steel to fill every corner of the mold, creating a flawless shackle body. After trimming away excess metal, the shackle moves to the grinding stage for smoothing. Next, the shackle pin and nut are manufactured. The pin is crafted from a 130-pound ingot. It is heated and pressed to form a hexagonal head. Threads are precision cut using a CNC machine to ensure a perfect fit with the nut, leaving absolutely no gap. Then begins the critical 3-stage heat treatment process: heating, quenching, and tempering. These steps make the steel incredibly strong, yet sufficiently ductile to withstand immense pressure without cracking. Once the shackle and pin are complete, they undergo a rigorous magnetic particle test capable of detecting even hairline fractures. Next comes load testing, where the chain is subjected to a 2,400-ton pull to check for any deformation in the links. After passing the test, the links are smoothed with grinders. Once cleaned, the chain is submerged in a 10-meter deep asphalt coating pool. This water-based asphalt forms a tough, protective layer on the links, capable of withstanding cold water, salt water, and ocean currents for years. Finally, each section is marked with a special stamp and assigned a serial number for future tracking. A massive crane then lifts the entire chain section and loads it into a container. This marks the beginning of their journey onto the decks of giant cargo ships. These chains are destined to battle ocean storms, towering waves, and deep sea currents. They hold fast anchors weighing hundreds of tons and safeguard cargo worth billions of dollars. Just think, these links, forged from ordinary steel bars, form the backbone of modern global trade, security, and maritime travel. Ultimately, when a ship drops anchor in the deep sea and comes to a halt, these iron giants spring into action. Whether facing thousands of tons of pressure or the turbulent currents of a stormy night, these chains never fail. This is because they are crafted through an extraordinary blend of fire, power, science, and expert craftsmanship. If you enjoyed today's video, please hit the like button and subscribe to the channel. See you in the next episode. Thank you.